Hello friends, welcome to Unacademy, which is the largest online platform for GATE Computer Science. Myself, Malisham Devasani. In this class, I'll be constructing the DFAs as we have seen in the previous session. We have constructed some DFAs and where we have understood how to construct a DFA, and we are still doing that construction. Yeah, so let's welcome to this platform. That is Vishnu. Good evening. Hello, how are you? Yeah, so please guys like this session before starting our class. Let me introduce myself. If anybody is watching first time on this channel, and let me introduce myself to you. I've secured all-day rank 119 and 210 in my BTech in GATE exam, and then I have completed MTech from IIT Bombay. Now I have almost 12 years of teaching experience in GATE, taking the GATE classes, and here I am going to teach TOC, compiler and programming. And if you are joining on Unacademy, use this referral code DEVALIVE to get 10% discount. And what are the advantages if you are visiting an Unacademy? More than 370 classes that I have taken so far on Unacademy, and similarly every educator has hundreds of classes are taken, and they are all available freely, and you can use that platform to learn something on Unacademy. So visit unacademy.com/DevaGate CSE. Like you have doubt classes, you have practice classes, you have regular classes, and these are all free. But when it comes to plus, the paid classes, which are courses completely, instead of 1 hour, 1.5 hour sessions, is completely you will have every day fixed timing, and they are completely structured. So far, if you look at my courses on Unacademy, I have taken TOC 2 times as the next level and practice course, and ultimate course, complete course on C compiler design, and complete course on C programming. Like you have doubt clearing course and fast track course on TOC is going to come soon. And if you look at the difference between the plus and iconic, there are two kinds of subscriptions we have, and plus and iconic almost they are same, except the iconic has more benefits. So all the plus benefits are there for iconic. Like every course is completely free once you have taken the subscription. And not only my courses, any educator, any course you can watch freely once you take the subscription. So you need to decide the subscription. Do you want to take 1 month or 2 months or 1 year or 1.5 years or 2 years? Then in that duration you can attend any course from any educator, any live class you can attend. And what are the benefits of iconic? You'll have a dedicated coach and live interaction with educators, separate study material, booster session, separate study plan, and personalized test analysis. And look at that, the price plans for both plus and iconic. For plus, I'm just describing first. For 1 year, 1.5 year, 2 years, you have 27,225, 34,650, and 39,600 after applying DEVALIVE referral code. And similarly for iconic, which are very popular 1 year and 2 year plans. Here you see that the 1 year 45,225, and after applying DEVALIVE referral code, and 66,600 for the 2 years iconic subscription plan. So you decide which one is suitable for you, because if you are the beginner, you want to crack the exam, then definitely iconic is the most suitable one. And plus is also suitable for those people they just wanted to learn from the educators, and they are already motivated and they are good at learning the things, then it's easy for them. And yeah guys, this is the GATE aspirants group for Facebook. On Facebook you can join this Facebook group to get regular updates from us, and this is active channel where you can subscribe on Telegram so that you will get the daily updates from us. We have various free YouTube channels you can also share with your friends so that they will also learn like you. Yeah, on this channel we have very good educators, and you see that, and every day we come to the live and we will take the classes, so that's beneficial for you. And if you're watching this video guys, please like the session. I'm waiting for your likes. Yeah, good evening once again everyone. Please like the session and also subscribe if you have not done it, and share with your friends. Okay, let's begin today's session. In the previous sessions of the theory of computation, we have seen finite automata construction, few problems. And before that, we have seen what is finite automata and how to write expressions and so on. And in this session, we will again continue that DFA, and then possibly we will also look at NFA construction. Yeah. So let's look at in the last class we have constructed 20 problems around. Yeah, more than that. Now we will start again constructing different problems. L is equal A star B star, and here I am just giving sigma is equal A comma B. We have only two symbols. Now how to design this motion? For this you need to understand the minimum string is epsilon. So you may design minimum string is epsilon. So I am designing it. If minimum string is epsilon, you must accept. Yes, we have accepted it. And after that, you know, there are two things. The A star, B star. So one self loop for A, one self loop for B is must. But who is going to come first? If both are there, A is going to come first. So we are going to put a self loop on A. So A star is designed. If you want B star, whenever P comes in case with A or without A, then you must accept it. Then after that, any number of B's you should accept. But here there is a problem. And in case A comes after B, we should not accept. We should go to dead state. This is the dead state. Yeah. So this is the motion, guys. Yeah, I'm fine. Shubhastri, yes, good. Good evening. Yeah, guys. All right. Clear this point? This is what A star B star motion. And if you look at A star, let me give you names for understanding this one. This is A and this is B and C. And if you are halting at A star you will accept. Here I'm just trying to help you how to understand. And if you are halting at B, definitely A can come any, but B followed by B star. So if you combine this A union B, you will see definitely A star B star concept. The A without B, capital B with B's. Right? But sequence is always same, A's followed by B's. Yeah. So let's focus on this second problem. Is it clear, everybody? And here so many points you have, like after A's only B's should come, and after B's A never comes. That's why after B's if A comes we will go to dead state, and every state A and B you should cover. So you should not miss any transition from any state. So because you know DFA. If anybody asks now what is NFA, guys? What is NFA? Just you require to design A and B state. You don't need a C state. Just dead state you can delete. You can say two states for NFA. Here we have three states in DFA, and in NFA you no need to design dead state, and two states enough for NFA. Yeah, the dead state is not required. So we will construct anyhow after some time. Now we have a different problem now which looks similar to the previous one, where here minimum string is B, and you must aware of that at least one B followed by any number of A's. Exactly, Nishu. Yeah, minimum string is the B. So now let's focus on minimum string. Your minimum string is a B. Yes. Now we have to change our focus to every state A can let's say A and B. From every state both symbols should be covered because our sigma is A comma B. And from capital A is missing. Is that capital is that a small a possible from capital A? Yes or no? That you have to understand. From capital A comes or not. If you look at the language, before B, A never comes. So if A comes from here, guys, if A comes from here, you should go to dead state. Because small a impossible now before small b, because after small b only A's comes. Yes. dead state is needed now for DFA. And after small b, any number of a's can come, any number of b's can come. Then how do you design that? Yeah, after 1b, any number of b's stay there. But in case a comes, then you need other state, and that is also accepted. But any number of a's, and after that b comes, then come to dead, because once you see the a, then you can't have a b. And here the number of states are many. Guys. At least 1b, then followed by any number of a's. Yes, everybody, from every state a, b covered or not, you just cross check from every state a, b covered or not, right? From this state b is there and a is there, from this state b is there and a is there. Sometimes we may not construct a minimum machine, so you must rethink, have you done correctly or not. And from every state both a and b covered. Yes. But if you want to design NFA, really this state, okay, capital D state is not required if you want to design NFA. So DFA, and I am writing 4 states, but you think about, is the 3 states possible or not? Are there any 2 states which are working like same? No, right? Yes. And 3 states in minimum NFA. But in future we have a minimization algorithm. We will see about that. How to minimize a given machine if you have not done constructed properly. Okay, next one. Oh, this is really going to be difficult, guys, because you have many symbols and there is always approach. Maybe I'm not speaking well, but you know, there is every state that you have. First focus on C. This is the first focus. Then second focus on A, and third focus is on B. Remember that the order of the symbols in a language also should be focused on order of the transitions in a diagram at every state, because that will help you to design the machine properly. Of course, once you have a practice, you can do any order, it will work. But as a beginner, you must go systematically while you design a machine. So my focus is on, okay, C you must have a self loop, and A you must have a self loop, and B you must have a self loop, because C's are any, A's are any, B's are any, but at least one C, at least 0A, and at least 1B. These are the conditions. Now this is a focus idea. Now minimum string we will begin. What is the minimum string in this language? Guys, what is the minimum string? That will help a little bit. C and B. C followed by B. A can be power 0. So now your focus is towards that CB. So I am designing now. Okay, C and B. And do not design randomly, as you know, this problem something different. DFAs are slightly difficult to design. Now, yes, CB is there. Now from every state ABC should be covered. As I told, think as I said. First think about C. Yes, C is already covered, right? From capital A, C is already covered. Now your focus is towards small a. Can I have a small a before C? That is your target. Can I have a small a before C? Because C is going to CB going to dead state. It's impossible now, because small a should not come before C. So once you go to dead state, you have A, B, C there itself. Now, can I have a small b before C? No. So A comma B you write. Yes. Everyone? Yeah, good evening Pratiksha. Yeah, good evening everyone. If I miss anyone, yes, good evening. And please like the session if you have joined late. And from capital A, every transition is covered. Guys, so far there was no self loop and we have not yet done my job. But from capital B, from state capital B, C, can I have a self loop? Yes, because C followed by C star is going to be accepted now. But in future there is something, at least one B should be there. And C covered, B covered, but A is missing. And after C, A can come, guys. But you can't stay there. You can't stay there. So what you do, you go somewhere. and it's some state, and any number of A's stay there, and if B comes, then you can come to the final back. That means with A, without A. If it is with A, from B you go to D and come back to C. If you don't get A, then after capital B go to capital C state, right? With A, without A, both concepts. And capital B state, A, all are covered. A, first which one? C. All are covered from capital B. C is covered, A is covered, and B is covered. Now focus on even C also. From C, is that C covered, small c? Is C impossible, because after B, C never comes, you should go to dead state. And after B, A should also never come, so C comma A. After 1B, any number of B's can come, so you can put a self loop there. You can put a self loop there. Yes. From C we have covered CAB. Then from D also you require to focus what happened to CAP. And from capital D, C never comes after small a, right? So you go to dead state. And A already given, B already given, so this motion is completed. And this is DFA. If you want to design NFA, dead state you can delete. Yes, 4 states you can save in NFA, but you will have 5 states in DFA. Yes, is it clear? From every state A, B, C covered or not. But I am following a particular order because here the sequence is very important. C followed by A followed by B. That is the reason I always think in that order. From that state C, A, B should be covered. They should be covered. Yeah. So this is the one of the difficult concept, because you need to focus on many symbols. So most of the people, they might have they might do the mistake. The reason is you don't have the patience to look at many symbols. So when you don't have the patience to look at many symbols, then obviously we do mistakes. And I'm asking a question. Do you have the self loop for everyone? Look at that. C we have a self loop, and A we have a self loop, and B also we have a self loop, because the C's, A's, B's can come any, but at least 1 or at least 0. That depends on the condition. Yeah, next one. Okay guys. Next, L is equal to n when there is nothing mentioned. N is integer. N is integer means here n greater than or equal 0 works, because -1 you can't keep here. Okay, so any integer. Now this is the condition given to you, and what is the meaning of this? It means double A whole star followed by triple A. The minimum string is here 3A's. This is actually looks like anybody guys? This looks like, don't say modulo problem, which will not work now. So first design triple E. First design to accept triple E. Then later on you can form that cyclic property. You can use the modulo concept. Every 2 A's you will come back to final, right? So you can take the help of the previous state. You can take the help of previous state. So every 2 A's you can come back. This will form, this is 2n, and from here to here it will form 3. So 2n plus 3. So total 4 states we have. And there is no symbol B, so definitely we don't need to create the dead state. Clear this point? Yes. Total 4 states are present in a DFA. But if anybody says sigma is equal to A comma B, then guys you require one extra state, dead state. From every state on B you should go to dead. If the sigma is equal to A comma B, then you will have 5 states, 1 extra dead. Here in this, 1 extra dead state is there. Here sigma is just A, so we don't think about a B, because they didn't mention about a B. Right? If they mention about the B, then you should be careful. You will have 5 states, because from every state a B should be covered. As they didn't mention about a small b, so you should not take it. In the language only small a visible, so yes, both are same guys. If anybody not aware of that, double A whole star triple A is same as that triple A followed by double A whole star is same as that A followed by double A whole star double A is same as double A followed by double A whole star small a. Everybody, This all are same. When somebody is saying a power 2n plus 3, you can say, right, a power 3 plus 2n. You can say that a power 1 plus 2n plus 2. You can say that a power 2 plus 2n plus 1. That is what I'm trying to do. All are same. Yes, same. Shubhasri, same. Okay, clear this point? You will have a 4 states. You will have 4 states. In the exam, you might have a shortcut. And here, see that this 3 is bigger than 2, right? So definitely 3 is the minimum string. So 4 states required. That 2 can be understood from that 4 states. Multiplicity of 2. Yeah. Another one. Here, directly you can't design for AAA plus 5A whole star. So you require to understand the strings of the language. Okay, minimum string is epsilon. And you need to try that arithmetic progression sequence. Let's see what is that. A power 3, because 3 is next. And next 5 is, you can come here. And this is just like a power 3 plus a power 5 whole star. And a power 6 I can get when you go twice. You can take a power 3 twice. You will get a power 6. Can you get a power 7? No. A power 8 you can get. How? One time you can take, even one time you can take a power 3. Other time you can take a power 5. Go twice inside. Go twice inside. Okay. A power 9. Yes. 3 you can take 3 times. A power 10. 5 you can take 2 times. And a power 11. That's 3 you can take 2 times. Then 5 you can take 1 time. And then so on. Every string is there after that. And to understand this concept now, and look at which one. Yeah, from this 8 A's, did you see that if you concatenate 1 A, you will get next one, again concatenate 1 A, so you can put a self loop once you reach a power 8. But to reach a power 8, you need 9 states. You need 9 states because you should guarantee epsilon accepted. Then 1A should not be there. This is the a power 1. And 2A should not be accepted. And if you go for 3A's, yes, you should accept. And 4A's, you should not accept. And 5A's, you should accept. And 6A's also you should accept. And 7A's you should not. But after that, 8A's onwards, you should accept everything a power greater than or equal to 8. So you can put a self loop on A. Yes. How many states required, guys? 12. Yeah. Understand. 12. Possible or not? A power 12. Is it possible or not? A power 3 you can take 4 times. No. 4 times that a power 3, a power 3, a power 3, a power 3 is a power 12. Possible. Come on. Pratiksha, possible. Everything is possible after that. Fine. So this is how you design. You require 9 states. Total 9 states. This was also previous gate question. And this same kind of question asked in the previous year. And that was the answer. That answer is also 9 states. It was already previous year gate question, guys. Fine. Did I take exactly same number of years? Yes. And similarly, if anybody want, we have so many varieties in that model too. Now, next. A number of A's is equal to 2. It means how many B's? Here A is exactly 2 and B is any. B's doesn't matter. B's doesn't matter, guys. And it's just like, A exactly 2. B is any. Did you remember the expression? This is the expression for this language. A is exactly 2, but B's are any from any place. Everybody? Yeah, this is an expression. But how do you design? Because first target the minimum string. Minimum string is AA. So focus on AA first. Okay, 1A and other A. Exactly 2 A's we have accepted. Now अब check करना है आपको. I can't get third A. If I get the third A, I should go to dead state. So I'm just designing, guys. Third A comes, I will go to dead, and definitely I should not accept anything after that. But now look at any number of b's can come before a. After 1a, any number of b's. After 2a's also any number of b's, because b's we are not counting here. So b's self loop everywhere. You can see that b's self loop everywhere. So this is the machine, guys. We have 4 states in DFA. If you ask me NFA, then I will have 3 states. Clear this point? Yeah. Now move on to the next problem. Yeah. And we are changing the problem, guys. Number of a's greater than or equal to at least 2 a's. Number of a's greater than or equal to b's, not mentioned, right? It's a greater than or equal 0. Nothing mentioned means greater than or equal 0. Now minimum a's. Now again the concentration. Minimum string is AA. Without 2a's, the string never satisfies the property of the language. Yes. Now again focus. Same kind of machine, minimum 2a's. But guarantee you are going to make a DFA here without mistake. But now change to your problem. Our problem is minimum 2a's. Third A onwards, I can stay here. Look at that. Is it clear? Now minimum 2 is guaranteed. Third A, fourth A, fifth A accepted. Now B's, I don't care how many they come. This state, and this state also. Now is it DFA now? Yes. You have 3 states now. You need to completely focus on your problem. Right? Every problem has a different criteria, and you should keep on changing your conditions as per the given data. A's at least 2, B's I have no problem at all because no condition at all. Yeah, clear this point, guys? Fine, next. And always focus. If I miss any transition from any state, please let me know, because we are making DFA. A's at most 2, it means okay, number of A's either 0 or 1 or 2, that is the meaning, right? 0 or 1 or 2, 0, 1 or 2, and number of B's is anything greater than or equal 0 because they didn't mention it. Yeah, now come to the point. Minimum string, guys. Oh, epsilon. Now this time we have to be careful. Epsilon accepted and single A is accepted. 2 A's also accepted, but not beyond that. If any more A comes, third A comes, we should go to dead state. And A comma B stay there. And B, we have no restriction at all. So we put a self loop at every state because B's we don't have any restriction. B everywhere you can see that it's a self loop. Clear this point? Yes, it is 4 states in DFA. In NFA you will have 3 states. That is not compulsory. It is not required in the minimum NFA. Then we can delete. Yes. Clear this point? So 4 states we have to answer in DFA. And in NFA you will have 3 states because you don't need a dead state. Minimum NFA will have just 3 states. Okay, now next one. This is the different one. In this only one string is there, guys. A power 1, B power 2. This comma represent AND. So it's just one string. It is equal just A double B. One string. A language has a one string. Very easy. Only you require to accept A double B. And remaining all combinations you should go to dead state. Remaining all combinations we will go to dead state. And here B cannot come. And after A cannot come because B we want, and A cannot come after AB. So after ABB no one should come here because it's just 3 length maximum and that is only the string you have. Yeah, 5 states in DFA. But in case if anybody asks, and you must say you have 4 states in NFA. I will show you after some time how to design NFA, but here just delete dead state, you will get NFA. Yes. Okay. Yeah. Next, 10th one. Okay, it's now slightly, the concept is going to be complicated, so you should have patience now. Now guys, m at most 1, n is equal to, guys, if you look at m can be 0 or 1, that is the meaning. Less than or equal 1 means if m is 0 but b is always 2, m is 1, b is always 2, and we have 2 strings, that is double b or a double b, that's all. And minimum string is double b. We can design this carefully. Yeah, b followed by b. Now if a comes, don't put a self loop, because if you put a self loop, double a also accept, double a double b also accepted. So a, you can go to somewhere, and b you can come here. So a double b will accept, a double b will accept, guys. Now apart from these two, every combination you are going to reach dead state. And here a cannot come after b, a never comes in our problem, right? We have only 2 strings, and after a there is no other a. Double A you can't see in any string in the beginning. After double B, there is nothing to accept. Now, this is the DFA. You can look at from every state A, B covered or not. Yes, yes. Thank you guys. Keep liking the session. Thank you so much, Nishu. Okay. Can you try this problem? Now n less than or equal to means n is equal to 0. Previous one was n less than or m less than or equal to 1 or 1 or 2. So here if you have a is always 1, but b can be 0 or b can be 1 or b can be 2. It's just 3 strings, like a and ab, a double b, guys. Only 3 strings we have. So you should maintain the state to remember all of them. Yes, and first a should be accepted, we did that, and next a b, so after a b also is accepted, we did that, and after a b then one more b also can come. Now these are the 3 strings are accepted. Now apart from these 3, everybody else is rejected, so we can create a dead state here. And from initial state b can come, from second state a can come, still that is invalid string for you. After ab a can come, after abb anything can come, all are rejected. Yes, this is your machine which has 5 states. And is it really minimum DFA or not? Only by experience you can understand, okay, this is the minimum DFA, because we are following the minimum strings. Most of the time you will get a minimum DFA. If you don't believe, we have an algorithm minimization, you can apply on it. If you get the same machine again, this is a minimum DFA. Yes. Okay, if anybody joined late, please like this session. Do not forget, guys. Okay, 12th one. And so far they are finite languages, so it's very easy to design. And m less than or equal 1, n less than or equal to, guys. So now you need to track both. Here you have m is either 0 or 1, n is 0 or 1 or 2. So 2 into 3, 6 combinations will have. So total 6 strings. A power 0. So a power 0, I will write b power 0, 1 or 2. A power 0, b power 1, b power 2. Okay. Any problem in the internet? Yes. And now a power 1 we have b power 0 and b power 1 and b power 2. Is that clear? So we have total 6 strings. And now this is okay, it's a finite language. It's a finite language so that you can understand easily. But if it is infinite language, guys, are you going to understand every string? No, right? So we will have some kind of logic like this. Okay, a power 0, b power 0. We can remember here. It's accepted because it's there in the language. And if a comes, the a power will increase, right? If a comes here, a power will increase. That's a power 1, b power 0 yet. If b comes, that a power 0, b power 1. And look at that, which is accepted here. A power 0, b power 0 already accepted. Now a power 1, b power 0 should be accepted. And a power 0, b power 1 should be accepted. And you need to understand how long we should go there. Second a, can you get it? Impossible, right? Second a should not come, right? So when second a comes, go to dead, because we don't need that second a at all. And third b comes, then you should go to dead, guys. Third b. Now here, after b, a should never come, guys. Remember, after b, a should never come. You know that concept. Sequence is very important. And after b, a should never come. And b, if you get a b, a power 0, b power 2. Is it accepted? Yes. So we will have the final state. And now the a power 1, b power 0, if you get one more b, yes, it is accepted, right? Because you have one b, a power 1, b power 1, it's also accepted. Yes. Only one thing left, a power 1, b power 2, that we can take care. And after a power 0, b power 2, a should never come, b should never come because third. And after b, a should not come. After b, the third b should not come. Both are going to dead. But a power 1, b power 1, b can come. So we will remember that. We will remember that. But after this, a should never come. So we go to dead. And after a power 1, b power 2, that nothing will come because they're all rejected. Because a should not come after b and third b should not come after 2 b's. And look at that, how complicated it is, guys. You require to design systematically. You should track every power to understand. And here the concept is, do not forget here, a is first, a is followed by b's. The concept is any a is followed by any b's. But in that any, this a's is at most 1a and b's is at most 2 b's. That sequence. That's why after b, a never come. If a's are coming, the second a never comes. If b's are coming, the third b never comes. So we need to track up to second b. We need to track up to second a. But a is followed by b's only. Right? Yeah, here 0 or 1 should be tracked, and 0 or 1 or 2 b's. Okay, this is how we design, guys. Now 13th. And it's a more complicated one. M greater than or equal to 1 means minimum 1. M is equal to 1 or 2 or 3 and so on. Infinite possibilities. N is exactly 2. Now it's just like a power greater than or equal 1, b power 2, guys. That means your minimum string, if you look at a double b and so on. So first focus on a double b count, guys, because that is a minimum string that has to be accepted. A double b. So this is definitely, we want to say that a greater than or equal 1 and b square you want to say there. But after reaching, guys, 1a, right, any number of a's you should accept. You don't need to remember them. So here a's can come any, because that can guarantee a greater than or equal 1. And this can guarantee a greater than or equal 1, 1b, b power 1. So now the minimum string here after reaching final state, then anything should be rejected because 2b is only max. And b cannot begin. So on b you go to dead. After 1a, a is covered, b is covered, that's okay. Now second, third state, that is after b, a should not come. And after double b, a comma b should never come. Look at, it's very easy. If the minimum string is unique and it's a different length compared to any other, it could be very easy to design. Yeah, 5 states required. Yeah, 4 states in NFA, right? And the only concept here people should understand, greater than or equal to 1 means after reaching the minimum condition on A, any number of A's you can put a self loop there itself. But after B, A never comes, remember that. Come on. Next. This is M greater than or equal 1 means M has infinite values, guys. And N, 0 or 1 or 2, only limited choices. Limited choices, guys. If anybody thinks about thinking about A's greater than or equal 1, B less than or equal to. So you have here A less than or equal 1, no B, or A greater than or equal 1, sorry, A greater than or equal 1 and B power 1, and A greater than or equal 1, B power 2. 3 choices we have, because B can be 0 or B can be 1 or B can be 2. 0 B's and 1 B's and 2 B's, because less than or equal to, guys. Now let's start designing. That is at least 1A, that is a minimum string. Minimum string is 1A. 1A accepted, and after that any number of A's is accepted. But in case B comes, okay, after that 1 B can come, or after that 2 B's can also come. So we have accepted that. Now we need to focus on all the missing combinations. Look at that. Capital B, capital C, capital D. The capital B does the first combination, and capital C accept the second combination, and capital D accept this last combination, guys. Okay, now initial state B cannot come because at least 1A, you should go to that state. And capital B is already covered both A and B, so don't worry. Capital C, A is missing, but after B, A never comes, we know. And after double B, third B is not there in the problem. Even A should never come after B's. Right, this is our machine. Again 5 states. Yes, again 5 states, guys. Again 5 states. Now similarly, can you try this? Here, I think dead state is not there because M starts from 1 and N starts from 2. Guys, dead state never comes now because the language is infinite, and also the M and N starts with some condition, but they have no ending length restriction. Now let's move on. Minimum 1A followed by 2 B's. So minimum A double B and followed by so many strings. And I'm trying to understand that A followed by double B. This is accepted. And guys, in that process, after 1A, any number of A's can come. Right? And this is after double B, any number of B's can come. So now look at this path can guarantee your NFA machine, guys. Right? This is NFA. This is NFA. Now every valid string you have a path here. You have a path here. But all the missing transition, there is a guarantee you require that. Why? You cannot start with B. And second state is covered A and B. Don't think about it. Third state A is missing. Final state A is missing. Now guys, if NFA requires, and if NFA it is a 4 states, if it is DFA, 5 states. Yeah. Right. Now guys, so far we have designed a DFA. Now let's focus on DFA versus NFA. Now in this case, how do you design DFA? How do you design NFA? Deterministic finite automata requires from every state, you will have one transition for every input symbol. Like starts with A. Minimum string is A, and we have designed in the previous class also. And after that A or B, you will be staying at final state, and B comes, you go to dead state. This is a DFA. Which DFA? Minimum DFA. And even that DFA is NFA, but it's not a minimum NFA. The minimum NFA is here. This is NFA. Here every valid string has at least one path. Invalid, no need to have a path. This is the minimum NFA. Look at that. Every valid string, do you have a path or not? At least one path? Yes. Invalid, no need to speak in NFA. So minimum DFA, no need to be minimum NFA. And minimum NFA, no need to be DFA here. Yes. So this is the difference between DFA and NFA. Here 3 states we have in DFA, and in NFA you have 2 states. And directly you can answer by looking at this one. Here by looking at this one, minimum string is A. Okay, minimum string is A, and you require 2 states to understand A plus 1 dead. This is for DFA. And NFA, dead is not required, so 2 is answer. Yeah. Clear this point? You can directly answer it if you know about all the starting conditions. Okay, next one. Ends with B. Guys, ends with B. And in DFA, we have a slightly complicated concept. And minimum string is B. So B should be accepted. And look at the concept. Ends with B, right? Whenever B ends, you will be at final. Whenever A comes, you should come to non-final. Look at that. Whenever A is coming, you are staying at non-final. But whenever B comes, you are going to the final. This ends with B DFA. And if you want to design in a way, so many ways, guys, so many ways. Look at that. I can design A comma B followed by B. This is the minimum NFA. Even this minimum DFA is itself minimum NFA, guys. Sometimes minimum DFA can be minimum NFA. Given machine, that's given, we have designed a DFA, right? That DFA is already minimum NFA. This is also minimum NFA. What did you understand? For any regular language, we will have one minimum DFA, but minimum NFAs can be more, one or more. Need not be unique. Minimum NFA, but minimum DFA is always unique. You will not have another DFA with the 2 states, guys. For any regular language, for every regular language, over sigma, only one DFA, only one minimum DFA exists. Only one is a unique here. But one or more minimum NFA possible. Clear this point? Yeah, DFA is only one, minimum DFA is only one for every regular, but NFA is one or more. Depends on the language. Yeah. So next one, this one is again DFA, NFA will try to design. This is the second symbol from beginning, right? Yeah. So first symbol is any, that is A or B, and second symbol must be B, and after that anything is fine. Here second symbol is not a B, you should go to dead state. So in general you have, like, you know, if I ask the question like, you know, nth symbol from begin is A or B, whatever, B, then how many states required? N plus 2 states in DFA. Whereas in NFA, just what you have to do, first symbol is A or B and second symbol is B compulsory. If not, we don't care. This is enough. And here 4 states in DFA, in minimum DFA, n plus 2 always, here n plus 1. Here n plus 1. For the same problem, n plus 1 states in minimum DFA. in minimum NFA, n plus 2 states in minimum DFA, n plus 1 states in minimum NFA, guys. Okay, so this is the DFA versus NFA. They could ask such questions in the exam, so without designing you can directly answer them. Come on guys. And here it's a very important when you compare a DFA and NFA. Here this is the second symbol. Similarly, I can apply for first symbol, third symbol from end. Second symbol from end is a B. And if you want to design a DFA, not at all easy. In DFA, you take nearly 4 states and very, very difficult. That is ends with BA or ends with BB. And if you are not understanding, you must use future concept to understand every state. And this is ends with BA or BB concept, right? There are 2 states, X and Y. X is for ending with BA, Y is for ending with BB. Now you need to understand if A comes from initial state, stay there. And I'm keeping 1, 2, and from 2 both A and B covered. From X, after BA, B comes, you have to look at, guys, after BA, if A comes, that is ending with double A is not there, so you have to remember that is you must go to back to the initial state to understand B's more, right? And after BA, B comes, then there is a chance this B can be second, so we can go back to the previous state. And after B, A comes, the BA already there as X, you can go there. And after double B, if B comes, it's ending with double B. This is a difficult problem in designing DFA, guys. Yeah, you can't merge 2 finals. If you merge 2 finals, tell me BA or BB. If you go to the same state, tell me after that B, should I accept or reject? BAB, you should reject. BBB, you should accept. Tell me, what do you do? If you combine BA and BB path, you will never understand how do you end in the future. And ending conditions, the final states must be separated. You cannot combine issue. It's not a starting problem. Starting with BA or BB, you can combine. Contain BA or BB, you can combine. But ends with BA or BB, you can't. Okay. So you need to practice. This is what the problem faces, and where you have the difference between YouTube and the Unacademy Plus. And this one, at least I explain 20 minutes how do you design this. But as you know, it's a crash course. Even whether I have not explained 20 minutes or not, you could have been understood what I'm trying to speak here. Now, this point, if you want to design NFA, very easy. Like, okay, you have any A comma B, and B comes, this is the second symbol from last, and last symbol is either A or B. Just you have 3 states, and you are looking for second symbol from end, then you will have 2 plus 1, 3 states. In general, nth symbol from end, you are looking for nth symbol from end is either B or A, but fix one of them. You will have 2 power n states in DFA, but you will have n plus 1 states in NFA. This is the main difference between the DFA and NFA. NFA's designing is easy. But understanding those machines will be difficult who doesn't know the definition of NFA. Yeah. Clear this point? Yes. Come on, guys. Next. Ends with triple A, guys. Okay, ending with triple A, DFA, no doubt. It's going to take much time, guys. Minimum string is triple A. Yeah. So your target is to end with triple A, right? Now B comes, stay there. After A, B comes, it disturbs the pattern. After double A, B comes, it disturbs as pattern. and after triple A comes, it's okay. Triple A followed by any number of is still triple A ending, but B comes, it's this old pattern again. So you must start from initial state to have a triple A again, right? So this is the DFA. Looks easy, but really not. And here minimum string is triple A, so somebody can understand dead states are not required for ending conditions, so directly you can answer 4 states. Because triple A is a 3 length. 3 length, to understand the 3 length, you require 4 states. Okay, in NFA, very easy to design, guys. This is the minimum DFA. And minimum NFA is what? You know, anything. It's okay. You don't need to guarantee A and B comes exactly once. No. Just follow your pattern. Just follow your pattern. This is your machine. Ends with AAA also have 4 states, but no need to design that difficult way. And this is also somehow minimum NFA. And there is another minimum NFA. And there are so many other NFAs also, guys. And here are so many NFAs which are minimum, guys. And so many other minimum NFAs. I don't want to disturb you, but still believe me that you have other. Apart from this, I can still confuse by writing A here, still the answer is same. I can write here, still the answer is same, guys. It will not disturb our pattern. Still that 3 yellow self loops, you can keep all of them, or you can keep any one of them, or you can keep any 2 of them. Still the answer is same, but all of them you will have 4 states, guys. All of them are minimum NFAs, but the first one is the minimum DFA. Sometimes minimum DFA and minimum NFA may have same number of states, sometimes may not. Okay, set of all 2 length strings over sigma is equal to A comma B. It's just like you have W, where W belongs to A comma B whole star, and they want 2 length, so length of W is equal to. So you know the expression, right? Expression is like A plus B whole square. A plus B whole square means A plus B you have A plus B followed by A plus B will guarantee 2 length. But do you want a DFA or NFA? If it is NFA, answer is over. If it is NFA, if you want NFA, an answer is over. But if you want a DFA, that you have guaranteed every transition from A, B, but C, you are missing A comma B. So you should have a dead. So NFA is just 3 states in NFA. And but 4 states in DFA. Minimum NFA, we should talk about minimum machines, guys. In minimum DFA. Yeah. Guys, keep liking the session. If anybody joined late, jaldi please like kijiye, and we have so many things to do. And here you can generalize it if you want it. You can generalize it. If length of the W is equal to N, if anybody asks here, you can answer it. N plus 2 states in DFA and N plus 1 states in NFA. You can generalize it if you want it. Yeah. And it is a length problem. Exactly 2 length you want. Exactly 2 length you want. This A is epsilon. This is A or B. This is double A, AB, BA, BB. So I want 2 lengths. So I made accepted here. And 3 length onwards. This is a length of W greater than 2. You are going to dead. You are going to dead. This is the length of W is equal to 2. You are accepting. This is the length of W equal to 1. Length of W equal to 0, guys. And what should I explain? Can't you understand what is 0 length? Come on, Dibandhu. इनको explain करना ही पड़ेगा. अरे 0 लेंथ है, आपको नहीं चाहिए ना. 1 लेंथ है, either A or B. इसको A comma B लिख सकते हैं ना. This is the length of 1. Length of the string is 1. अगर आपको 2 length आ रहा है, this is going to be 2 length. That you want to accept now. And just you want 2 length. Over answer. 2 length से ज़्यादा कोई string ही नहीं है दुनिया ये language में. तो more than 2 length. So that's the length of W greater than 2. That's a dead state. Stay there. That's a dead state. Over. Yes, come on here. track the length. That's what I did it here. Understand the problem. What do you want? Just exactly 2 length. 0 length not accepted, 1 length not accepted, but you have to wait for the 2 length. After 2 length, 3 length onwards, go to dead. Don't go 0 length, 1 length to the dead. Remember, don't go to dead. Okay, let's move. And as at least 2 length, guys, at least 2 length means minimum 2 length to hona hi chahiye and followed by any length. And how do you guarantee minimum 2 length, guys? 0 length. And if anybody don't understand, write it. Okay, this is 0 length because wo epsilon hi stop hoga वहाँ पर. This is going to be 1 length. How do you know it is 1 length? Because you are designing it. What are you designing? I am keeping a comma b. Means every 1 length I will stay in that 1 length state only. And you want minimum 2 length, right? This is you want to accept. Here you have length of w greater than or equal to 2. तो यहाँ पर accept कर लो. A comma b के बाद any number of a's and b's stay there. अब इसे पहले आप reject कर रहा था, अभी accept करो. Right? This Martian is the DFA, and NFA also you can assume this one because for NFA also you can design this way, and you will have 3 states in NFA and DFA. Even you can design NFA other way, but still you will have at least 3 states because minimum string length is 2, so you can't avoid 3 states. You can't avoid 3 states, guys. All right. Now at the most 2 length means 0 or 1 or 2. 0 length I accepted. This is the 0 length. That is epsilon basically, guys. Epsilon. And 1 length a comma b when you write, and 1 length accepted. So this is basically we say it a plus b power 1. If you want to understand the meaning, and if you give one more a comma b, this will become a plus b whole square. Because a plus b followed by a plus b. I'm writing the meaning of the state, guys. Don't worry about the states, names. Okay. At most 2 length. That is 3rd length should not be accepted, right? So after that any symbol comes, you should go to dead. Because this will be more than 2. And you should reject. So this is equal to 0 length. This is equal to 1 length. This is equal to 2 length. You want at most 2. Accepted now. At most 2. Yes. 3 states for NFA, but 4 states for DFA. Everybody, at most 2 length is 4 states in minimum DFA and 3 states in minimum NFA. Okay, in general, if they ask at most n, then you can form accordingly. If this is n, then this is going to be n plus 2 and 3 is going to be n plus 1. If this is, you are assuming n. Yeah. Next one, AP whole star. Guys, here you know that sigma has a comma b. They will provide you when they want to have a clarity. A comma b is mentioned because here 2 symbols are there. And if you are designing DFA, guys, look at how do you design. Epsilon accepted. And after every AB, you should come back to final. So AB also accepted. But if you want to design DFA, here directly B should not come. Here after A, one more A should not come. So here you will go to dead state. This is about DFA. But NFA is so easy, guys. In NFA, what you do, you just make A followed by B, come back to final. 2 states enough in NFA. But for this you require 3 states. 3 states in minimum DFA. And here sometimes you require to apply minimization algorithm because random expressions, random languages are sometimes difficult to express the machines. So whatever you design, try to apply the algorithm later on, so that you will have a clarity, is your machine is minimized or not. Okay, not yet, we have not seen it, but I will explain, guys, what is the minimization algorithm. Guys, I can see the likes, number of likes are very less. Please, if you are watching this video, keep liking this session, guys. Please, thank you so much. And 10th one, guys, L is equal to epsilon over, guys, I'll explain little bit. First one, assume, okay, I'm just making here, it is a 1 and I'm taking one more, 2. L is equal to epsilon only, but over sigma is equal to A. Look at the difference, guys. And if you are designing DFA, epsilon accepted and A comma B, you go to dead state. This is how you say minimum DFA. And if you want to say minimum NFA now, you can just say one state. This is minimum NFA, guys. Minimum NFA. You don't need to specify A comma B from every state. Look at the difference between minimum DFA, minimum NFA. And this is only one minimum NFA in the world which accepts epsilon. There is no other minimum NFA. So sometimes you can have one state also, one machine also, guys. And another one here, epsilon accepted, but A is only there. So you go to dead and there you will have a self loop A. So this is the minimum DFA. Here you have two states and here minimum NFA again looks same. Because I don't need to mention any symbol because I don't have any symbol in my language. But Sigma has, but language is having only one string, empty string. Minimum NFA. Clear this point? DFAs, they are looking different, but number of states same. And NFAs, they are looking same because of epsilon. Okay, guys, this is how we understand. And today we have seen most of the problems, like NFA, DFA, constructions. And in the next class, we will see how to convert. In the next class, we have constructed some problems here. How to convert NFA to DFA. In the next class, we will see how to convert NFA to DFA. Then what is the relationship between the NFA and DFA exactly. Next class, I'm going to explain. But you know that DFA versus NFA. In DFA, we have seen this is the definition. Q cross sigma derives Q. And that is only the definition you need to remember mainly. Q cross sigma, if you have epsilon, that is epsilon NFA, which will be 2 power Q. Are you clear? This is the main definition of DFA and NFA, guys. Yeah. In next class, how we can convert in NFA into DFA. And remember, note, every DFA is already NFA. Every DFA is NFA. And you can call any DFA as NFA, but NFA, non-deterministic NFA need not be NFA, but NFA need not be DFA. Remember that. That is the reason we require an algorithm. If you want to say DFA and NFA are equivalent, then you must show. If you want to show that DFA equivalent to NFA, then you must prove that there are two algorithms. Already we know every DFA is NFA by definition. You don't need to convert any DFA. Already it is NFA. But NFA to DFA, you must have an algorithm. So tomorrow in the next class, we are going to see the subset construction. Yeah, how to convert that, guys. Okay, let's see in the next class. And if anybody not aware of the plus, guys, remember the plus always have live classes and interactive classes and so many educators and so many courses, and you will have a complete course, complete syllabus which will be taken by many educators, and you will really benefited from the plus subscription. And you will have a crash courses and regular courses and long-term batches, short-term batches. So many different batches are there. It's and you can sit for any batch any number of times, guys. No restriction at all. It's not like a physical offline coaching, guys. There if you go for one batch, you are not allowed for other batch. But here inside the platform, everything is free, but only you have to take the subscription. For how many months you want to take the subscription, you decide. And you can use any referral code to get the discount. And once you enter into the platform, and almost everything is free. But Iconic has additional advantages, like you will have a code separately, and you will have a study plan, you will have booster sessions and test analysis, a separate study material for you, and all the benefits of plus. Additionally, you will have more benefits in Iconic. So if you are interested, you can ask me anytime how to get benefited from this Unacademy. And this is my profile. You can follow my classes on Unacademy. And thank you so much. Please like and share with your friends and subscribe. Don't forget, guys. Thank you so much. And this is my referral code. DEVALIVE is my referral code to get the 10% discount on Unacademy, as well as you will get my guidance to crack the GATE exam. Thank you so much. See you in the next class. Bye bye. Take care.